1.7 million now.
The particle menagerie.
1.750.
Menagerie. Menagerie.
1 million eight.
Menagerie.
Menagerie. A collection of wild animals kept in the captivity for exhibition.
50. We're great.
A strange or diverse collection of the people or things. Menagerie.
Moving on.
The first evidence of the new particles was found in the cloud chambers that experimenters had built in their labs to record the pulse of the charged particles. Right.
Let's see what
Cloud chambers consist of a sealed tank full of the supersaturated vapor of water and alcohol. The supersaturation is such that any charged particle passing through leaves a trail of condensation behind it. Carl Anderson, a physicist working at Caltech, had used these cloud chambers in 1933 to confirm the existence of the new a strange new sort of the matter called antimatter that had been predicted some years earlier by British physicist Paul Dirac.
on the screens for you.
Yes.
There it is. The wonderful brass wire sculpture.
Dirac's attempt to unify quantum physics and the theory of electromagnetism had successfully explained many things about electrons, but the equation seems to have a complete mirror solution that didn't correspond to anything anyone had seen in the lab.
900,000. Just off the back of the record-breaking Hong Kong.
Dirac's equation were a bit like the equation x squared equal 4.
You'll be at 2,900,000.
There is a solution x equal 2, but there is another mirror solution, namely x equal minus 2. Yes, please think about the graph of the parabola,
Back of the phone
because it is square. The x is squared.
in Hong Kong.
Because minus 2 times minus 2 is also equal to 4. The mirror solution in the Dirac's equation implied that there was a mirror version of the electron with a positive charge. I didn't know this process. So sexy, huh?
I'll take 3 million to
Most thought this was a mathematical curiosity that emerged from the equation. But when 4 years later, Anderson spotted in his cloud chamber traces of the particle behaving like an electron in a mirror, antimatter went from the theory to reality. Wow, I didn't know this story.
400,000.
So sexy, huh?
Still with EP now in Hong Kong at 3-4.
Anderson's positrons, and as they came to be known, had been created in the particle interaction happening in the upper atmosphere, and they weren't the only new things to appear.
50.
Right.
Gets you both. 3,500,000. Back with Brooke Lampley. Thank you, Brooke. At $3,500,000. It gets you Yuki, and it gets you Brad at 3.5. So the second row there, the middle row.
Even stranger particles that had not been predicted at all were soon leaving trails in Anderson's cloud chamber. Anderson started to analyze these new processes with his PhD student Seth Neddermeyer in 1936. The new particles corresponded to a negatively charged particle passing through the cloud chamber, but they weren't electrons. The path these new particles were leaving indicated a mass much larger than that of the electron. Wow! Just as Thomson had done, mass can be measured by how much the particle is deflected under the influence of the magnetic field. Wow!
That's the Dubuffet here from 1963. Wonderful surface on this picture. And I'm going to start the bidding here at 2,100,000.
The particle seems to have the same charges as the electron, but was much harder to deflect. Wow! Now called the muon. It was one of the first new particles to be discovered in the interaction of cosmic rays with the atmosphere. The muon is unstable it quickly falls apart into other particles, most often an electron and a couple of neutrons. Neutrons were another new particles that had been predicted to explain how neutrons delayed into protons. With almost no mass and no charge, it took until the 1950s before anyone actually detected these tiny particles. But they theoretically made sense of the both neutron decay and the decay of the new muon. Wow. The decay rate of the muon was on average 2.2 microsecond, which is sufficiently show that enough particles won't have delayed by the time they reach the surface of the Earth. Yeah. The muon helped to confirm Einstein's predictions from the special relativity that time slows down as you approach the speed of the light. Wow, everything is connected. Given its half-life, far fewer muons should be reaching the surface of the Earth than were being detected. The fact that time slows down close to the speed of light helps explain this discrepancy. If a clock was attached to the muon, it would show that a smaller interval of time had elapsed before it hits the Earth. Thus, more muons would therefore survive, as revealed by experiments. I will return to this in the fifth edge when I consider pushing time to the limits of the knowledge. The muon appeared to behave remarkably like the electron, but had the greater mass and was more unstable. When the American physicist Isidore Lavie was told of its discovery, he quipped, "Who ordered that?" Yes, I remember this quote. Who ordered that? It seems strangely unnecessary for the nature to reproduce a heavier, more unstable version of the electron. Little did Lavie realize how much more there was on the menu of the particles. Right? It's the entrance of a mystery, right? Having realized that cosmic ray interaction with the upper atmosphere were creating new forms of matter, physicists decided that they better not wait for the particles to reach the cloud chambers in the labs, by which time the particle might have decayed into the traditional form of matter. So, the cloud chambers were moved to high altitude location in the hope of picking up other particles. Yo, wow.
And we move on, lot number 14 has been withdrawn.
The Caltech team closed the top of Mount Wilson near their home base in the Pasadena. Sure enough, new tracks indicated that new particles were being picked up. Wow.
2,300,000, 2,300,000, 2,400,000, 2,400,000, anymore, 2,500,000 with Sarah Pritchard now, 2,500,000.
Other teams placed the photographic plates in the observatories in the Pyrenees and the Andes to see if they could record different interactions. Teams in Bristol and Manchester also saw traces of the new particles in their own photographic plates. It turned out that the muon was the least of Lavie's worries. Wow. A whole menagerie of the new particles started showing up. Wow. Some had masses about 1/8 that of the proton or neutron. They came in positively or negatively charged variates and were dubbed pions. An electrically neutral version that was harder to detect was later discovered. In Manchester, two photographs from their cloud chamber showed what appears to be a neutral particle decaying into the pions. The mass of these new particles was roughly half that of the proton. The cloud chamber at the top of Mount Wilson recorded more evidence to support the discovery of what would become known as kaons, 4 in number. Wow, kaon.
and 2,100,000. It gets you grey. 2,200,000. The total from any person is. So globules of 2,200,000 directly the same.
As time went on, more and more particles were uncovered, so much so that the whole thing became totally unwieldy. As Nobel Prize winner William Lamb quipped in his acceptance speech of the 1955, the finder of a new elementary particle used to be rewarded via Nobel Prize, but such a discovery now ought to be punished by the $10,000 fine. The hope was that the periodic table would be simplified once scientists had discovered how it was put together using electrons, protons, and neutrons. Yes, but these three particles turned out to be just the tip of the iceberg. Now there were over 100 particles that seems to make up the building blocks of matter. Really? As Enrico Fermi admitted to a student at the time, "Young man, if I could remember the name of these particles, I would have been a botanist." What irony, botanist. So much names you have to memorize, right? Rather than understandings. Just as Mendeleev managed to find some sort of the order with which to classify and make sense of the atoms in the periodic table, the search was on for a unifying principle that would explain these new muons, pions, kaons, and other particles. The understanding structure that finally seems to make sense of this menagerie of the particles. The map, as it were, to find your way around the zoo. Ultimately came down to a piece of mathematics. Yes.